Hi everyone, how's it going? Here's our critical features review and revamp, as well as a tie-in with results interpretations. And part of this is going to include how to set yourself up for success when you go into collect data and reinforce some ideas and some strategies there. And yeah, again, what to do once you get the data. That's really important as well. Okay. So as far as where this as far as where this, sorry if again I'm coughing or clearing my throat or sneezing or anything like that throughout the lecture. I'm going to try to go back, pause it where I can, but I might catch you and off guard or might miss one when I go to edit. So I apologize for that in advance. Um, so with your projects currently, we've covered so much already. That's so great, and we're in the final stages here. So we've done all of this work. We've even covered and reviewed what your whole QMD is going to look like. You should have your step 2 or part 2 of your IMA available for you for guidelines wise for you to be able to go through. Um, for for today's lecture, we're going to go over data interpretation. So once you've collected your data, what do you do with it? A little bit, going back and touching base on how to set things up well for yourself there. But once you have the data, what do you do with it? What is it telling you? How are you going to interpret that? At least a starting point for that. And then also, how is or what's a good starting point for you to go back to your critical features for finalizing those, and as well as how do you incorporate your data that you've collected into your range of correctness for your critical features, because that's so important for the diagnosis component of step 3. So again, just placing this in your QMD cycle. Realistically, we're going back and revisiting kind of this phase, even though we haven't gone through the whole process yet. We're going to go back and look at the critical features and revisit those, flush them out, make them stronger, as well as range of correctness for the critical features here in the evaluation, or so the diagnosis phase of your QMD. Typically, I really try to segregate and give you information in a very flow, logical sort of manner, and separate concepts as best I can for you. But today's really does kind of flow and cross over into one another. So um, yeah, and it should make sense once we go through it. But we're going to go back and revisit how do you actually go about testing your hypothesis? Because you have this working hypothesis with your critical features currently. So how do you go back and actually test that? And how do we double check and make sure that we're testing what we want to? How do we apply that to our critical features when we revisit that? And then from that point, we're going to have some sort of results. And how do we integrate that into figuring out our range of correctness? And again, you might see there's a little bit of overlap or cross support between each of these ideas and these concepts and these processes, but that's why we're doing it in today's lecture. Okay. So if we, again, just try to figure out where we're at in the process, we've done quite a few points. You have your hypothesis. So we're kind of at the point where we're thinking, okay, you're going to go to the lab, you're going to collect your data, and then what do you do with that? Well, you need to apply it and figure out how to use it for your critical features, as well as your range of correctness. And how do we finalize that? That's the big goal from today's lecture. Setting you up for, giving you more support and setting you up for success for your lab data collection, interpretation, and application. We'll revisit testing your hypothesis. And I think the main point here is we want to check the validity of what you're testing. So again, you'll get some feedback from part 1 on this, but ultimately you should go back and just double check, ask yourself some questions. What I am hoping to measure in the lab actually what I want to measure? Is it actually going to look at the variables that I believe is critical feature that's important to this. So what do I mean by this? Well, explaining validity typically is if I go out to a parking lot and I want to get into a vehicle and drive somewhere, um, is the object I'm actually getting into a vehicle or the car that can get me there. So am I stepping into a cardboard box? That's not going to get me where I want to go. Am I getting into a boat? Well, it's kind of like a vehicle, but it's not going to help me travel on land. I want to get into a car. So again, validity is the test. So say I'm testing a vertical jump, um, and I'm testing EMG of the quadriceps or something like that, the quadriceps, and I go to jump and I see a big spike of activity. Well, is that actually telling me that there's more muscle use there, and therefore that muscle activation's more critical to vertical jump, or is something else going on there? Am I actually maybe accidentally measuring some sort of I don't know, hamstring activation? Maybe I placed the electrodes wrong or something. So yeah, I'm going to change that. So another example of validity is if I'm trying to measure the successful accuracy of, say, a volleyball serve, and I split the court up into a certain way, let's say, just say front and back of the court. Is that really a valid way of testing for accuracy, or should I maybe divide the court up into smaller segments? Should I have a smaller target to hit? Should I have a person on the other side, etc.? So really kind of revisit your current measures that you have set up for yourself. Okay. The other component is you want to make sure you try to avoid confounds or confounding variables in what you're measuring. And a big part of that is trying to ensure that any extraneous factors that also might explain your results are controlled for or limited if possible. Now, this isn't always possible, but identifying them and stating that you're aware of them and things that you can't control is important. So one of the most common confounding variables in health studies is SES, or socioeconomic status. It's really well known that those of higher SES status, so more resources, more income, etc., tend to score higher across the board on pretty much every health metric out there. So when you're looking at your measures, try to see if there's any outside or conflicting or confounding variables that might influence your results. Okay. The second point here, aside from going back and checking the validity of what you're measuring, is it actually measuring what you want to, and is there no extraneous factors involved, is thinking ahead to what you want or expect the results to be and look like. So another way of saying that is, how do you know your hypothesis would be supported? What does that look like? And a lot of students will get into the lab, measure a bunch of stuff, and then have this data and kind of not know what to do or expect with it because they forgot to tie in one more component. And it usually goes along the lines of logistics and just making good records and tracking along while you're in the lab. So what do I mean by that? Well, let's go for, let's say, a javelin throw, and you're looking at your data and somebody throws a javelin 10 times. You measure, let's say, shift of balance, so force plate between the left and right foot as they go to throw, or dominant, non-dominant foot. And all of a sudden you have all this force plate data. You get home and you go to analyze it, and you forgot to track, which throws were successful and which weren't. So all you've measured now is just how somebody happens to throw a javelin 10 times and what that weight shift is, which might be fun if you have an elite thrower. It'll give you a good average data set and a range to work with. But really, you want to make sure that the data that you're collecting is of good throws. I mean, even expert throwers tend to have not so good throws. Excuse me. And so, yeah, you want to be able to set yourself up for success and ensure that you know what you're looking for and what information you'll need to make those conclusions when you get into the lab. So it just takes a little bit of planning ahead. Okay. So go ahead, take a moment, pause the video, chat with your buddy or just or your partner, or just go through the material on your own and just give a couple of minutes to go through these points. Validity. So when you're checking validity, a good way to do this is, what is the gold standard for measuring the metrics you're after? So what do I mean by that? Well, every metric or variable out there has a gold standard that you usually test for, or with, sorry. So for example, for body fat composition, the gold standard is full submersion water displacement tests. Now, are we able to do this all over? No, because we don't have dunk tanks and proper equipment for that. It's a fairly complex piece of equipment in the sense that you need to have space for it. So what do? We use other tests like skin fold measures, bioimpedance. So one thing to double check is, what is the gold standard? And then how is yours comparable to the gold standard? And for some things like EMG and force plates, it very well could be the gold standard. And so if you're using that for the variable that you're looking for, great. Okay. The other quick and easy-ish way to check to see if what you're measuring is valid is just checking in with your peers, being like, hey, I'm going to do a measure where I'm going to I'm going to put an accelerometer on someone's wrist as they do a baseball throw. What sort of information do you think I'll get from that? So without prompting them and just explaining what you're measuring and what you're looking for, they should be able to tell you, oh, well, yeah, that sounds like you're probably going to try to find acceleration of the arm at the wrist, or maybe angular acceleration or something like that. And then you can be like, yes, okay, that's what I was hoping to do. That's what we're measuring. Okay. And then double checking again for thinking ahead. How are you going to analyze the data once you have it? What sort of results will tell you the information you're looking for? And at what kind of point or what threshold, we'll get to this a little bit, are you going to consider data as supporting your critical features or not? Sorry, just a second. So that was kind of your testing hypothesis, again, trying to set you up for success when you get into the lab. And now we'll get into more of the critical features themselves. A little bit of it's review, and some of it's a bit of a new take and a different view on things. But it's all good to be reminded of. Okay, so our critical features. Once we have our lab data attained, we want to analyze this data and interpret for our critical features and see if there's support for it. And the other thing we'll get is some sort of range of data or spread of data, and that's going to go and directly help influence and dictate our range of correctness. Okay, so if you determine if that data that you've collected is in line with previous research, your hypothesis, your expected results, etc., then that's great. It's kind of like supports, you're good, you can start moving forward with it. If not, you need to take pause and try to determine why. So one, maybe you need to go back in and just remeasure things. Maybe you identified a source of error in your measurements, video, whatever it happens to be. So this is why it's good to try to collect your data early, just in case you need to do that. Or at the very least, you need to speculate why there's a difference between stated research and your findings. Maybe it's the difference in populations that were measured. Maybe it was just something new and novel that your critical feature happens to highlight that other research doesn't. Part of this will be boiling down and ensuring that you have kind of the bare bones, the essentials of your critical features. So recall that I think I've even highlighted 2 to 8, but 4 to 8 critical features will be dependent on the skill, which will help highlight essentially one critical feature per phase that you have. So you can have an additional 1 or 2 that just globally might be applied across the skill, but generally you want to try to keep about one thing for your coach to evaluate or view or observe during the performance of the skill. And the reason for that, well, we're all humans and we can only really attend to one-ish, maybe 2 things at a time, especially if the movement is really, really fast, right? So yeah, we want to minimize the amount of focus points that we give our coaches and our movement experts to do. Okay. So again, that will be after we get our data, after we see kind of some evidence to support the really critical features. One of the tricky parts occasionally that can occur, and you should speak to this at some point in time, potentially in your presentation probably, is that when we're just looking at one mover, it's sometimes a little tricky to identify the difference between a critical feature and ideal form, okay, or preferred form, okay. So my favorite example here is, one of my favorite examples here is the difference between free throws and the percentages. So if we were to truly look at what an ideal form would be, is percentage-wise, free throw baskets go in a greater percentage of the time by a magnitude of about 10 to 20% more with an underhand shot versus overhand. But you can see we have this player here. He is actually pretty amused that we have our free thrower here doing an underhand shot for the free throw. But statistically, this player would make many more shots than the player on the left. And so part of this influence in trying to identify what's opinion, critical features versus ideal or subculture norms is just that. You're trying to differentiate the two. So when you're going back and revising and revisiting your critical features, put on a little bit of a critical thinking or a skeptical cap on as you're trying to look through this and you know, see what is truly a critical feature versus ideal or preferred form. Okay, and that's can be challenging because, you know, depending on the shooter and the environment, movements are very, very dynamic. And so again, this is where your data is going to be pulled in to help you make your statements and or previous research. Okay, so those are last few points. So making sure I have the right number of critical features, trying to differentiate it from idealized or preferred form, making sure it's well supported by the evidence or the literature, et cetera. Those are kind of like revamping things. This is a bit of a new point, okay? So when you have a critical feature, one of the most important things, so again, the whole point of your QMD or this IMAKE project is you want to provide some sort of evidence-based information and content to coaches, movement practitioners, to be able to practically and actionably help athletes or people improve their movement. So how do we do that? Well, we need to give some sort of phrasing or wordage for people to pair critical features with. Okay, so what do I mean by this and how do we go about this? So, well, we need to give our critical features things called cue words. So a cue word is a short phrase or a term, can even be one word. If you're getting up to 4 words, it's a little lengthy, but it's meant to prompt an action, a desired action. And this relates back to our topic when we were talking about knowledge of process, so the feedback and how the body moves and how to give movers that. Additionally, when you're giving feedback, if you recall, you want to try to give a goal of what you want your performer or your mover to do, okay? So again, trying to get rid of a negative feedback train where you're always giving critiques and giving instead a phrase or a goal for them to move towards, okay? Let's look at a specific example or examples here, okay? So if we look at our critical features and cues for a soccer instep kick, so just like a step and kick for, with the inside of your foot, we have our list of critical features here, and then the keywords associated with each. So you'll give this in your part 2 for sure when you're going through your intervention. Okay. So we'll go through a couple of them. The first one is not so biomechanically heavy, let's say. So eye focus, head down and watch the ball. So this is for the soccer kick. So eye on the ball is another way of saying that. Okay, so it's a focus point. Really, we could even boil this phrase down more. You just say, watch the ball, or head down, watch the ball. You know, try to get to as few words as possible. The idea is you give the athlete a whole bunch of background information when you're speaking to them on the side and say, when I say head down, watch the ball. I want your head down like this. So you're demonstrating, you know, look at the ball all the way through, even when you kick it, and whatever, right? So you're trying to tie in that cue to a critical feature, and you're giving them something they should be aiming towards. Head down, look at the ball, okay? Another example that I like, maybe a bit more better, a bit more tangible, and this will probably be reflective of more of your cues and critical features that you've developed, is solid impact. So again, I don't like the phrasing necessarily of this critical feature. I think, you know, in your descriptions of your critical features, you've expanded a lot more. This is fine for a table, you know, but kick through the center of the ball. So for the critical feature, I'd say, you know, a bit more of a biomechanical version would be applying force to center a massive ball and ensuring that you have a follow through, right? So kick through center a ball, that's cues. You could even shorten that, I think. I think that's a bit longer. You could say just kick through the ball, right? I think that's pretty, that could be helpful, okay? Yeah, so hopefully that makes sense. You know, you have your critical feature and a cue word. So again, it's going to be a point of this where you're going to be asked in part 2 to line this up in your intervention section, okay? But just in case have left this up for subsequent years and I might have changed it, just look at your assignment outline, okay? Okay. So the last point here is just being aware of what may or may not be critical factors, critical features, sorry, but what's can still influence performance when you're going through your evaluation. So leaving space on your evaluation sheets or trying to be aware of differentiating a critical feature versus an external influence or influential factor are these points here. So critical features can be attentional, as we noticed on the last one, but certain factors that aren't are psychological, emotional, physiological, and physical. And that can vary, okay? So usually you want to leave some sort of space or area for mention of these potential influences in your evaluation component, okay? And this should kind of make sense. So for example, If you're measuring someone in the lab, you're seeing them perform a golf swing. If someone is trying to show off psychologically, like they're trying to really smash the ball, it's going to change how they perform the swing for sure. Similarly, emotional states will affect motivation. If there's fatigue, that will definitely change performance, and physical. As far as vision, kinesthetic, haptic is touch sensation. So how does that come into play? Physical maturity is like post-adolescence or pre-adolescence, etc. So again, I think we can imagine how these influences could impact performance while we're measuring, but they wouldn't necessarily dictate the performance of a skill based off of a critical feature, something that absolutely must be there. But again, as you're going through your evaluation of your sample person, or when you're developing the form for your evaluation sheet, you might want to leave space for some of these factors. A good place where this would come into play, where again, not a critical feature, but is a factor that can influence performance, would be pole vaulters. So novice pole vaulters who are younger, or of any age really, it's kind of intimidating and a little fear-provoking, the thought that you're going to run up to this little hole in the ground, jam in a really long pole, lean back on it, and get shot up, let's say 10 meters in the air. Like that's pretty, it's definitely reasonable to have some fear invoked there. So again, as a coach, it's important to kind of notice these things and potentially intervene on them, but they're not necessarily a critical feature. Okay, and again, that's up for you to decide, but just be aware of that. Okay. Okay, so we covered a bunch of different points. We've spoken about how to look at our data and make sure it's supported, or if it's not supported by research, what do we do then? How do we look at our critical features and make sure they have the right number? Is it truly boiled down to the minimal amount, which is best because that means our coaches don't have to attend to as much information? And how do we differentiate critical features and potential performance influences, and how does that work? Again, just trying to separate them. And probably the most newest piece of information that really should be brought into the fold for you is how do we add on keywords onto our critical features to be able to give something actionable for our coaches, right? Okay. So we've kind of looked at our critical features. Let's move forward on to taking some of our results. How do we interpret them? And just as importantly, how do we use that as a range of correctness, or how do we put that towards that? So we have a few points here, and it's really just trying to set you up for success again in the lab. Okay, so know ahead of time what results will look like. They'll help guide your collection and set up your collection sheet, or data collection, tracking, or logging. And we'll give you a specific example of that next. So it's a way that you can essentially organize the data as you collect it to almost give you your interpretation as you're gaining this information. Once you have that, if you haven't already, you should have some idea of what your threshold is going to be as far as supportive data versus not. And last but not least, you want to use your data to help determine your range of correctness, and that will come from your collected data and how you're planning on interpreting it. Okay, let's look at an example here with some specifics for you. So before you head in, again, you want to have an idea what you're looking for, what information you're collecting, and how that will help you out. Okay, so here's kind of an example of a data collection sheet that you might make for yourself. Everyone's is going to look a little different. Again, depending on what your hypothesis is, what your critical features are, what you're measuring, what you're hoping that information is going to tell you. Okay, so again, knowing the validity of each of your measures before you head in is going to be really helpful here. Okay, so we have our number of trials. Again, being aware of how many trials you want your participant to go through is going to be very helpful. It should be predetermined. We've spoken about this in a previous lecture. So you want to have, depending on the skill, a reasonable amount of trials. So I just said I made something up for dart throwing. So I want to know, as far as accuracy, did this person hit the target or not? Okay. So yes or no's here. But also, equally importantly, whenever there's a successful hit, I want to know what that data is as far as how long their eye tracking is. So eye tracking is how long someone has a fixed gaze on a particular object or target. So I'm going to do that in time. So I have all my time measures here. I also want to know when successful targets are hit, so throws are accurate. What's the velocity of their wrist, as about their elbow. I want to know if they shift their weight lots between their feet. And I'm just going to leave a little section here of qualitative notes and observations I might make generally about the performer or what I observe about their performance. Okay. So what I can do now when I have this data, and I thought of this before I went in, like, okay, this is going to be my goal. The like critical features are, good eye gaze, good higher angular velocity versus lower, minimal weight shifts, and that just those three. Okay. So I collect my data. I see there's 2 yeses, 1 no. So what I'm going to do is when I go back and I do my analysis, I'm going to compare these. Okay, I'm going to say, okay, when the target was hit, our thrower had a significantly longer amount of time with a fixed gaze on the target. Their angular velocity was on average, three times as much as when they missed, and they were much more stable when they went to throw. I noticed that they're more focused and had less prep time when they went to throw, and the few times that they were distracted beforehand on their throw, like laughing and making jokes, talking lots, they were less successful. Okay, so it's just kind of setting up my table here, and again, seeing successful throws versus not successful was really helpful here for a good performer. Now, there's other ways you might be able to set this up for yourselves, okay? Maybe accuracy isn't as important for you. Maybe it's reaching a certain height threshold. Maybe you're comparing just purely elite throwers to non-elite throwers in this. I would still try to keep track of successful versus non-successful throws in that instance, but there are situations and movements where you're just purely comparing across conditions and looking for the certain variables, okay? And again, once we start getting to that point where you're analyzing this data, it's kind of up to you, and because it's not a stats class or there's no expectation that you do statistical analysis here, you can just do a relative percentage average comparison between the two, okay? Like I was saying, on average, angular velocity for successful throws are 6 meters per second, per radian, right? Or radians per second. That's the wrong unit anyway. Just caught that. Yeah, so that's one example of how you can treat the data. But the other thing you can do with this, which is really, really important for range of correctness, is you can look at this data and say, okay, on successful throws, the amount of time spent gazing at the target point for any fixed amount of time on average was between 0.87 and 0.91. that should be seconds, maybe not milliseconds, but that's the idea, okay? So now you have this range of correctness for when successful throws are made, okay? And that's how you can quantitatively define your range of correctness. And then you can start converting that to maybe like a qualitative scale as well, okay? But again, this will be all very skill dependent. And I would expect over the next couple of weeks for sure, as people are collecting their data and getting their data and trying to interpret it, that we'll be setting up some Zoom meetings or chatting during the class time that you have to work on this project. Okay, because it's kind of a pretty key step there. Okay. So defining thresholds and trying to figure out essentially how do you define what a successful attempt at a critical or at a skill is, right? So to do this, and this might be done after you get your data. So for some of you will know before obtaining your data, and I would highly suggest if you can to do it that way before, is operationally define your variable. So what does that mean? Well, you have a variable or something you're trying to measure, and it's a little bit abstract, doesn't make a lot of sense necessarily as far as being defined as, say, successful. Like, how do you define that? How do you define a successful, let's say, long jump? How do you define a successful tennis serve? How do you, so all of these are not necessarily very clear, right? How do you say, how do you define that a hockey slap shot is accurate? Okay. So as whatever your variable is that you're trying to measure, you just have to be very specific and very clearly identify it, okay? So that's going to require some threshold cutoff, okay? That's up to you to kind of discuss and figure it out for your specific skills. After you get your data, you are going to need to figure out what you want as a significant threshold for well-performed skills, okay? Each skill is going to be a little different, but you need to make a cutoff. So for example, if you look at a accuracy of an elite, let's say a basketball player making free throws. I got it here, okay? So an elite level player will make about, on average, about 75-77% of free throws, okay? So with that being said, if your elite player is only making 40%, how is that going to interpret or how is that going to affect your results, right? If you have a elite basketball player that made 90% of their shots, well, great. Okay, that should be very representative then of what a great free throw would be, right? So determining where that significance level is important. If you have half of the shots being made and there's a big shift in body weight for a golf swing, and there's the same number of body sways happening in 50% of the shots that aren't being made, well, now you need to decide, is that actually a critical feature? Is that being supported or not? 50-50, is it 60-40? Yeah, so again, ideally you find some sort of support or higher level evidence, and there's some out there for a lot of skills, stating percentages and how you can weigh that, okay? And then trying to use range and define. I kind of mentioned it on the last slide already, but it's essentially the highest and lowest values. Sometimes there might be an outlier and you can remove that as far as your data if it just is really going to mess up your range and you see the average of most of the range within a certain area. But you need to state if you're eliminating outlier data and your reason behind it, okay? Okay. As far as your range of correctness, how it's important, why it's important, etc. Essentially, this is really, really helpful in giving you a clear definition. Once you have certain, say, joint angles for range of motion on something for range of correctness, you can actually say it and people will visually be able to estimate that relatively well. Now, they've done studies on this, and physiotherapists and other movement specialists do this a lot better than those with less experience of visually looking at joint angles and determining this. But um, it can still be done if you give those parameters, even a quantifiable parameter. Okay, if you can translate that to a qualitative perspective or something to watch for. Maybe you're talking about velocity and you're trying to communicate that higher velocity at certain points in the phase are better for a skill. So for example, let's say the popping up from a squat jump, the faster velocity, the better, the higher ground reaction force, etc. If you're not expecting your coaches to actually be able to measure these things regularly, then you need to convey that into a qualitative factor that they can then use on a scale. Okay. As an extra bit of information and what to expect to see when you're looking at your range of correctness ranges. For closed motor skills, it's going to be a lot smaller of a range versus an open skilled motor skill. And again, just as a reminder, closed versus open. Closed is when your end of your limbs are in a bit of a fixed position or on a fixed item. The easiest example that I can think of right now is like a leg press machine. Your feet are fixed on the platform. You're pushing. That's a closed motor skill. An open motor skill would be something like, let's say, a soccer kick, right? Running, you're not really fixed. You have a free leg swinging. Your upper body's free. It's not fixed or seated or anything like that, okay? Okay. And then while you're going through this, both for your evaluation, but also in your data, obviously you need repeated trials. And depending on your skill or what you're doing, that might change how many attempts you have. Is it 5? Is it 8? Maybe 10? If you're getting up to 50, that's definitely way too much. But again, we spoke about that in a previous lecture, okay? And when that repeated, this is what you do in your evaluation phase, if you recall, once that repeated performance occurs outside of your range of correctness, well, it needs to be changed due to safety or performance, right? Okay. So when you're going through your evaluation, you've come up with your range of correctness ranges, you've determined what's good. Now you can give some numbers, some range of motion. This is for a vertical jump, just something I kind of made up as an example or a sample. You want to come up with a scorecard, right? Again, we want coaches to be able to readily, quickly, easily see some of these numbers and be able to record and score this information. So in this case, this coach or movement specialist has a force plate, and they're objectively, qualitatively just going to look for a range of motion on these different joints and give a score out of inadequate, in range, or excessive. So if it's in range or above or under, or whatever, it's really quick for them to just watch and go like IA, IR, E, watch a trial and plug in those features, okay? And this shouldn't be in line with this. This should be like a whole new chart probably, but they can also have some quantitative feedback for different trials. So trial 1, maybe in here, put that in there. Trial 2, trial 3, right? And then they can say how much was the range of correctness within that percentage of their body weight as far as the ground reaction force on the vertical jump, yes or no. So just yes, yes, no, no. and that's all they need to do, okay? So that would be if you're making a scorecard or an evaluation sheet for your part 3 of your QMD. Okay, and that's how you apply the range of correctness after you've managed to sort that through and define what is within the range there. Okay, all right. So that is the review. That's it for there. Again, this is meant to just get you started. It's not necessarily meant to give you all the answers that you need right away for your specific skill. Again, everyone's data collection is a little different. Skills are a bit different, but it should at least give you a starting point that you can then adapt to your own skills. Okay. Okay. So go ahead, start arranging to get into the lab and collect data. Email Ryan now, collect that data. Again, email me. Let's set up a Zoom meeting to prep you for that, and or once you have your data, let me know. When you go to do these things or come to these meetings though, have ideas formed, have done some research, have a working thought or line of thinking or whatever, and it's not a come in, hey, are we right? It's kind of like a come in, hey, here's what we're thinking, here's where we're stuck. Okay, and I understand that there's going to be some uncertainty with your working hypothesis, but come to me with like some legwork done, some thought, some points where you feel like you're getting stuck on as far as what the next steps are, or seeking some clarity. Okay, good. And then again, that can help you with some data analysis or analyzation uh, and or interpreting the data. Sorry, and and reassessing those critical features. Okay. Just as a side note, when you go to submit for your assignment for the critical features, just read through again. There's just a couple little changes that you'll need to do for that. Okay. Okay. Anyways, thank you so much. That's it for this. Again, email with questions, set up a Zoom session, whatever, and we'll chat soon. Good luck. Have fun collecting data in the lab and testing your hypothesis.